Good morning, ladies and gentlemen. I'm very pleased to be speaking at the Drug Delivery to the Lungs Christmas Lectures for 2020 and to present our study on the carbon footprint assessment of Breezhaler dry powder inhaler on behalf of my co-authors. Just very briefly on disclosure, I'm a partner at ERM, which is a global sustainability consulting firm. My team and I work on assignments for the private sector and industry association clients across most sectors in the economy, including in healthcare. And in healthcare, we've carried out work for a number of major organizations, including Novartis, who commissioned this study, and also for the Sustainable Healthcare Coalition and for the National Health Service in the UK. So by way of introduction, climate change is recognised by the United Nations as one of the defining issues of our time. In order to gain a handle on contributions to climate change and their mitigation, we use techniques loosely bundled as carbon footprinting, which is quantifying the greenhouse gas emissions at every stage through the life cycle of a product or service. Respiratory inhalers make a significant contribution to the carbon footprint of healthcare, estimated to be 3% of the footprint of the NHS in the UK. And this is largely connected with the footprint of high greenhouse gas intensity hydrofluorocarbon propellants, which are used in pressurized metered dose inhalers or PMDI. As a result, switching from PMDI to a dry powder inhaler, DPI, which does not use a propellant, can result in a very significant opportunity for greenhouse gas reduction. And there are several studies of this in the literature. One that I quote here indicates that the saving could be as much as 150 to 400 kilograms of CO2 equivalent for one device used for a year. That's roughly the same as switching to a plant-based diet, so a very considerable reduction indeed. Moving on to our study, it was a cradle-to-grave approach, spanning all stages in the life cycle from raw material extraction through processing, manufacture and transport to use and end-of-life management. And we looked at two Breezhaler combinations, indacaterol acetate, IND, in my later slides, and momentazone furoate, MF, and a second combination which adds to those two, glycopyrronium bromide, or GLY, on the remainder of my slides. So this slide shows a system boundary for our study, and in this case indicates the boundaries used for the IND GLY MF product, and includes in this case an optional sensor, which is shown in the diagram. The Breezhaler IND MF boundaries are the same, but exclude this optional sensor. Both of those two products, IND GLY MF and IND MF, are sold in 30-day packs, and the IND GLY MF product is also sold in a 90-day pack where that's permitted. The carbon footprint study has looked at Germany, France, the UK, and Japan, and there are differences there in terms of end-of-life management and packaging and distribution. And we've looked at all pack combinations, as you'll see on the subsequent slides. So moving on to the scope of the analysis, the optional sensor I mentioned before, available in combination with a once daily Breezhaler for IND GLY MF only, and it provides inhalation, confirmation and adherence data. The sensor will last for 12 months, and it's paired with up to 12 inhalers if you're looking at 30-day packs, or 4 inhalers where the 90-day pack is available and permitted over that time. For the 30-day IND GLY MF product, we've looked at this both with and without the sensor. For the 90-day package, we've only looked at it without the sensor. And the study boundary excludes potential sensor benefits which might result from the reduction of asthma exacerbations, from the use of rescue medicines, and generally from improved adherence. So moving on to the functional unit for the study, this is the unit of analysis, which typically encompasses the specific function of the product, the duration over which the function is fulfilled, and the expected quality of the function if that's applicable. In this case, the FU is defined as an inhaler device used for 30 days to treat a patient, differentiated according to the characteristics of the country, France, Germany, the UK, or Japan. And that FU is representative of the 2019 data collection period. It's important that the functional unit for any comparison is an equitable one, and so we've employed the same functional unit for all devices, including both the 30-day and 90-day packs, and therefore the IND GLY MF product has been a 90-day device has been assessed for a 30-day period. So that comparison is apples with apples. And moving on to the results of the study, you can see here that the carbon footprint is very similar for Germany, France, the UK, and Japan. The 30-day devices without the sensor, whether that's IND or IND GLY MF, have a very similar footprint in all cases. The highest footprint is the IND GLY MF device with the sensor, and the lowest footprint is for the IND GLY MF device over 90 days, which is significantly lower than the other three devices in all cases. Moving on in a little bit more detail, here we see for Germany alone, the carbon footprint on a per day basis and a per month basis. Essentially, the picture is very similar, although of course the carbon footprint itself differs. The two 30-day devices without the sensor have a very similar footprint. The IND GLY MF with a sensor product has the highest footprint, and the IND GLY MF product for the 90-day pack has by far the lowest footprint. Breaking out just for Germany again, the contributions to the carbon footprint by life cycle stage, we can see that the inhaler raw materials and the production energy used in the manufacture of the device make the most significant contributions, and the sensor raw materials do as well where they are used. Packaging and API are slightly less important, and the excipient and distribution impacts are minor. In the case of Germany, there's no end-of-life impact because all of the product at end of life is assumed to be either recovered or recycled, and the benefits associated with that are assigned to the use of that secondary raw material or energy. And so here we see the results by life cycle stage across all 4 countries, and the picture again is very, very similar. API makes the largest contribution to the IND GLY MF 90-day device. That's between 33 and 34% of the whole carbon footprint. The largest contribution for the IND MF and the IND GLY MF devices without the sensor is the inhaler energy consumptions, between 27 and 30% of the total carbon footprint. And finally, where they're used, the sensor raw materials make the largest contribution to the IND GLY MF device with a sensor, responsible in that case for between 22 and 23% of the total carbon footprint. And lastly, to conclude, I think I've talked about most of these points, but overall, when considering inhalation therapy environmental impacts, the Breezhaler portfolio assessed has a low carbon footprint, and that's consistent with the rest of the literature that we see looking at DPIs and MDI comparisons. Thank you very much.